Hey, this is Don from Padlock Technologies here again to talk about I guess we're going to talk about the Fusion router and SDA. Got a question about that, like what's the purpose of it? Why do you even need it? So I'm just going to do a quick video to answer that question. So let's get to the whiteboard here. So the first thing we're going to talk about is the Fusion. Let's make sure we get a pen here. So we're going to talk about the Fusion router and SDA. So the Fusion router and SDA is basically going to be the rendezvous point, or the technically the egress point or the meeting point between the SDA fabric and shared services. So if we draw this out actually, so let's say, so shared services would consist of like ICE, AD, Catalyst Center, formerly known as DNAC. WLC would be outside of this, right? WLC, not WLL. So let's see here. That's what we call shared services. And the reason why it's called shared services because it's exactly what the name is. It's shared services that everybody uses in the campus network. So downstream from that would be the Fusion router. So Fusion. Now, all because they call it a router doesn't necessarily mean it's a router. It could be a router. It can be a firewall. It can be another switch for all you care. All right. This is just to provide connectivity between the fabric, or SDA fabric, and shared services, or outside of the SDA fabric. And then the Fusion router will connect to either a dual or a single border node. All right. Depending on your design, there's going to be L3 connectivity between these two. Now, between these two, you're going to be running MP BGP, right? Multi-protocol BGP. And in SDA, I had another video comparing SDA, but in SDA, they have these things called VNs, or virtual networks. Technically, under the hood, they're just VRF tables. That's really all they are, but they just decided to call them VNs. In ACI, they're called VRFs. So that's basically all they are. So let's say, for example, you had 3 VNs, and I did this in the other video, but I'm going to do it in this one. So you have VN, it's going to be corp, that's for employees. You have VN for guests, and then you have a VN for IoT. So when you do that in the fabric, it basically creates 3 VRF tables. So I'm going to say green is for corp. We'll say red is for guests, and then we'll do yellow for IoT. And from a BGP perspective, underneath the hood, each of them are going to be their own. From a BGP perspective, they would be their own address family. So AFI, sub AFI. All right, for each of these. And what happens is the Fusion router's only job is macro segmentation. This is not micro segmentation. Micro segmentation will be within the same VN. Macro segmentation, or micro segmentation, will be within the same VN. Macro would be VN to VN, right? So what would happen is this Fusion router, and let's say this network for shared services 192.168.10/24. All right. So you have whatever IGP behind here. Let's say you are running EIGRP or something. So that network would be in your routing table and your topology table from an EIGRP perspective. And then from BGP, you would need to redistribute these EIGRP routes in the BGP, which will eventually get on the border. So the border would be chopped up into infra VN. Now, infra VN is by default when you do fabric, and then all the other networks get chopped up, right? From a logical perspective, right? From a logical perspective. Now, what you would do is you're going to redistribute. You're going to do something on the on the Fusion router, which is in each VRF. You're basically going to import and export the table, right? So you're going to import from the global routing table or the GRT, where this ERGRP route is, into each individual VRF table in BGP, and then you're going to export from the VRF tables in the Fusion router into the global routing table. So when you see, when you look for a route that's in, let's say, Corp, in the global routing table, it will say, let's say Corp subnet was 192.168.2.0/24, just for simplicity's sake. When you look at the global routing table in the Fusion, and that would be this routing table here, it would say 192.168.2.0/24, and then you would see something that has VRF yes in there, or VRF Corp, if you want to call it that, VRF Corp. And that's how you would actually leak the route from the VRF table into the GRT, and then GRT knows how to get that. Now, that mutual redistribution would also happen because now in each individual VRF, they would see the global route going back up to the Fusion, and then the Fusion would know the global routing table is where you need to look. So that is really the purpose of the Fusion router or firewall. You don't have to do this in a firewall because you can make everything in the global GRT or GRT, because if you say global GRT, it's kind of redundant. You can keep everything in a GRT, and then you just do your policy enforcement based on, you know, basic firewall rules and zoning and stuff like that. But if you're using routers, you're going to have to leak routes in between the GRT and the VRF table. And that's the purpose of this device here, which is the Fusion router. So hopefully that video was informative, gave you a little explanation about what the Fusion router is. Now there's more components in SDA. Obviously Fusion router is one of them. Border nodes are the second one. Control plane nodes is the third one. Fabric edge nodes is the fourth one. Your border node can be your control plane node if you do not have a separate device that's just strictly control plane. Again, hopefully this video was informative. If you need any assistance on your network infrastructure project, I'm going to leave some links in the description. One's going to be on ICE, one's going to be on SASE, one's going to be on just generic network infrastructure projects. Hopefully, I talk to you soon. If I don't, you at least learn something today about Fusion routing. Keep sending me questions and I'll answer it when I have time. And I put videos out a lot, so just keep flooding me with questions and I'll keep flooding you guys with answers. Thank you and have a nice day.